Hello. So today we'll be solving three progression and series problems with increasing difficulty. So let's start. This is the first problem, that is let Sn, S2n, S3n are respectively the sum of n, 2n, 3n terms of an arithmetic progression, then S3n will be equal to. So first of all, in any kind of questions like this, in these kind of questions, we first see the options. The options tell us that we have to calculate S2n minus Sn. See, in every option there is S2n minus Sn. So we'll calculate that. So Sn, I think I will use a different color for this. Sn is n by 2, 2a plus n minus 1 into d. S of 2n is 2n by 2, 2a plus 2n minus 1 into d. So let's calculate S2n minus Sn, which will be equal to n by 2, let's take as a common. This will be multiplied by 2. So 4a plus 2d into 2n minus 1 minus 2a minus n minus 1 into d. So this will be n by 2. 4a minus 2a will be 2a. From these two we will take d. So 4n minus 2 minus n plus 1. Okay. So this will become n by 2. 2a plus 4n minus n, which will be 3n. This will be minus 1 into d. This is S2n minus Sn. What is S3n? It is 3n over 2, 2a plus 3n minus 1 into d. This is basically 3 times this. So S3n is 3 times of S2n minus Sn. Simple. So our answer will be option C. So this is the first question. It was a pretty easy question because the options were easy. We clearly knew what to do. We have to subtract S2n and Sn. So we have pretty straightforward question. Let's go to the next one. Okay, now let's move to the second question. If alpha and beta are roots of equation this, and gamma and delta are roots of equation this, these are in GP, then this. You can pause and try to solve this question. It's a bit tricky, but I think you can solve it. Let's go ahead and solve it. So from quadratic equations, I know alpha plus beta is minus 2b upon a, and alpha beta is c upon a, right? Similarly, gamma plus delta is minus 2q upon p, and gamma delta is r upon p. These are the 4 equations that I need, right? These are in GP. Alpha, beta, gamma, delta are in GP. What that means is this is A, this is AR, this is AR square, and this is AR cube. That's how they are in GP. Let's use these equations first. Alpha beta is A into AR, which is A square R is C by A, and gamma delta is A square R to the power 5, right, is equal to R upon P. Let's divide these. We will get R to the power 4 is equal to R upon P C upon A, right? So this is what we get. This is our first equation. Let's use these two now. Summation. So A alpha is A, beta is AR is equal to minus 2b upon A. Gamma is AR square plus AR cube is minus 2q upon p. Let's take a common from this. This is 1 plus r is equal to minus 2b upon n. Let's take a r square common from these. 1 plus r is minus 2q upon p. Let's divide these two. We'll get r square is equal to minus 2 minus 2 gets cancelled. Q upon p and b upon a. So squaring these, a square q square upon b square p square. I am writing r to the power 4 from this is equal to a square q square upon b square p square. Right? And from here it is ar by pc. ar by pc from equation 1. Right? So this left a. This is P, right? So Q square and B square के terms में आया ना? So AC upon B square is equal to RP upon Q square. Let's check the option. AC upon B square is equal to PR upon Q square. So basically that's the answer. Answer A. This was an interesting question because we have to use progression in series and quadratic equation at the same time. So it was a very interesting question. Let's go to the third question. This is a difficult question and I think you should definitely try this. Pause this video and try this. The common difference D of an AP is non-zero. The common ratio of GP is a positive rational less than 1. A1 is D, B1 is D square, this is M. M is a positive integer, then M is equal to. Okay, so A is a AP and B is a GP. First term of an AP is D. So its second term would be D plus common difference, which is D, which is 2D. Third term would be 3D. Right? And R के बारे में कुछ बोला है क्या? Common ratio of GP is less than 1. It's less than 1. So वो वाला use करेंगे. But it's positive. Okay. So R is between 0 and 1, right? So B1 is B square. So B2 must be D square R and B3 is D square R square, right? What do we have to calculate? A1 square plus A2 square plus A3 square upon B1 plus B2 plus B3, which is M. So A1 square would be D square, 4D square and 9D square. 9 plus 4 is 13 plus 1, 14D square upon D square common ले लो, 1 plus R square. So this will get cancelled. So basically 14 upon 1 plus R square is M. Okay, so let's see M की values कहाँ से कहाँ तक जा सकती हैं. R is between 0 and 1. So R square would be between 0 and 1. So 1 plus R square would be between 1 plus 1, 2 and 3 and 1 plus 0 plus 0, 1. So this is its range. So M की range जो होगी वो होगी 14/3 से लेके 14 तक, right? What are the integer values? This is 4 point something, right? So m is 5, 6, 7 up to 13, right? These are the positive integer values because m can only be integer, right? Positive integer. M can only be a positive integer. So these are the values that m can take. What else can we do? 14 upon m is equal to 1 plus r square. Let's make this a perfect square. R square plus r plus 1 is 14 upon m. R square plus 2 times of half of r plus 1 by 2 का whole square is 1 by 4 is equal to 14 upon m. Right, so this is r plus 1 by 2 का whole square, right? And this is plus 3 by 4, उधर जाके minus 3 by 4, right? So this should be a perfect square. This should be a square, right? Let's put the values. m ये हो सकता है और ये perfect square होना चाहिए. Let's see. r plus 1 by 2 का whole square, right? r plus 1 by 2 का whole square is equal to 14 upon m minus 3 upon 4, and this should be a perfect square, right? Let's check for all the values of m. m is 5, 6, 7 up to 13. Let's check for 5. 14 upon 5 minus 3 upon 4. 20. 56 minus 15. 1 and 4. This is not a perfect square. 14 upon 6 minus 3 upon 4 is equal to 3 and 7, 12, 28 minus 9, 19 upon 12, not a perfect square, right? 14 upon 7 minus 3 upon 4, this is 2, 4, 8 minus 3, 5 by 4, not a perfect square, right? Let's check 8. 8, 14 minus 6, which is 8, 1 perfect square. So we get m as 8 and r as, r भी तो calculate करना पड़ेगा, r plus half का whole square is equal to 14 upon m, ये तो calculate ही किया है 1, right? So r is equal to plus minus 1 minus 1 by 2, so r is half and minus 3 by, so तो कोई point नहीं है, r is half. So r is between 0 and 1. एक second. r is between 0 and 1 and m is a positive integer which is between 14 by 3 and 14. So all criteria satisfies, so m is 8. What was the question? Then m is equal to, so m is equal to 8. I hope you found this useful. This was a pretty good question. You should have solved it, but if you could not, then you can see the method. Hope you learned something. Thank you.